Welcome to Module 4, City Performance Indicators and Methods of Assessment. If you can visualize human metabolism, you can also visualize urban metabolism. Have you seen the urban metabolism of Brussels? What is emergy? It sounds a lot like energy, but with an M. What does it take to gather data for a material flow analysis? Early studies using life cycle assessments started in Europe. What was their motivation? Can we really apply life cycle assessments in cities? How does the Greenhouse Gas Emissions Inventory of Paris tell us a bit about the touristic city? The fourth module of this course provides an introduction to a number of methods of assessment. These methods may have been historically applicable to other industries or fields of study, and that will be presented as well. Their application is demonstrated in cities using city-specific metrics to enable an objective and quantitative performance evaluation of cities. This module may seem quite analytical. By the end of this module, you'll be able to evaluate the performance of cities quantitatively using several methods of assessment as a learning outcome. Then you'll go through the topics of this module. In a series of videos, you will learn about urban metabolism, energy and material flow analysis, environmental life cycle assessment, and greenhouse gas emissions accounting. In the first video, you will learn about urban metabolism and how the concept developed through time, starting from the very first urban metabolism study by Abel Woolman, which draws from his paper, The Metabolism of Cities, then on to circular metabolism, and you'll see some examples from some of the earlier studies, in addition to more recent resources for urban metabolism by pointing to examples sourced from the website metabolismofcities.org, which is home to publications and databases on urban metabolism in cities, and a very interesting online animation to visualize urban metabolism of the city of Paris and Île-de-France, and offering some thoughts on a review of urban metabolism by Kennedy et al. In their paper, The Study of Urban Metabolism and Its Application to Urban Planning and Design. In the second video, the concepts of energy and material flow analysis are introduced as two schools of thought by first presenting the founders of these approaches, Howard Odum on energy, and Bacchini and Brunner on material flow analysis. This is followed by a step-by-step guide to a material flow analysis via an application in cities, with references to key articles on this topic, including The Changing Metabolism of Cities, Metabolism of Neighborhoods, A Mathematical Description of Urban Metabolism, and Mainstreaming Urban Metabolism. In the third video, environmental life cycle assessment is introduced, primarily from the book The Hitchhiker's Guide to LCA, including summarizing some early examples from the United States and from Europe, in the United Kingdom, Germany, and Sweden for typical applications to materials and products, and sharing insight into the motivation behind these life cycle assessment studies, which is then followed by applications of environmental life cycle assessments in cities as they are applied to individual buildings in the paper on life cycle environmental effects on an office building which is located in the south of Finland, and in neighborhoods, specifically two neighborhoods in the Greater Toronto Area, from the paper Comparing High and Low Residential Density, Life Cycle Analysis of Energy Use and Greenhouse Gas Emissions. In the fourth video, the basics of greenhouse gas emissions accounting, which is used to develop a city's greenhouse gas emissions inventory, is presented, with reference to a paper on greenhouse gas emissions from cities, comparison of international inventory frameworks. The paper also presents inventory examples from New York, Shanghai, and Paris, which are demonstrated in brief, and wraps by introducing the Global Protocol for Community-Scale Greenhouse Gas Emission Inventories, which is the international standard currently used by cities globally. And to give you examples from global cities, you'll see city performance indicators for urban infrastructure that includes Boston, Buenos Aires, and Taipei, from the World Council on City Data, the WCCD, where you'll explore metrics for environment in Boston, solid waste in Buenos Aires, and water and sanitation in Taipei. And examples from African cities, there's Cape Town, Minna, and Chouani, also from the World Council on City Data, showing transportation in Cape Town, energy in Minna, and wastewater in Chouani. A module summary in the form of a checklist to recap what was presented appears at the end of the module, followed by a quiz to test your comprehension and a chance to join the discussion to reflect on the material by contributing your thoughts on the ways in which cities can learn from one another in light of these city performance indicators and the abundance of data collected in cities. Should you want to look further into the readings, have a look at the sources listed under references. Unique to this module is a reflection point. It's a chance to reflect on the material covered so far in the course, while observing the pros and cons of the city that you live in or another city of your choice, in addition to your own ideologies. In your own words, you're encouraged to define a sustainable city and indicate the elements that are required to build a sustainable city. Your thoughts on sustainable cities formulate an urban design theory. What would you name your theory? And what are the principles of this sustainable design?